Okay, so looking at number 5, it says cotangent x is equal to 1, so we have our trig function equal to a number, so we're good on that. If you look at your interval, it's a little different this time. It tells you negative pi to negative pi over 2. So those are not actually on your unit circle. We're going to have to find the coterminal angles to see exactly what that means and where we should look. So if you remember, coterminal angles are a circle apart. So in radians, they're 2 pi apart. So for negative pi, if we add 2 pi to that, that'll give us pi. And for negative pi over 2, if we want to add 2 pi over that, so we want to have the same denominator, you would add 4 pi over 2. And that'll give us 3 pi over 2. So we can think about this. We want to look in the interval from pi to 3 pi over 2. Okay, so looking at your unit circle, from pi to 3 pi over 2, we're talking about quadrant 3. So we're going to right now just solve the problem just like we did the other problems. We're going to look in quadrant 3, but when we get finished, we're going to have to go back and make sure our answer is between the original interval that they gave us. Okay, so we'll go back to that. So cotangent, we know it goes with tangent. Okay, so tangent is y over x, so we know cotangent is x over y. So we're trying to figure out when x over y is equal to 1. Okay, the only time that ever happens on your unit circle is whenever you're going to have the square root of 2 over 2 divided by the square root of 2 over 2. Now, they could be positive, negatives. So remember, we're looking in quadrant 3. So if you look in quadrant 3, here we have negative square root of 2 over 2, and we have negative square root of 2 for the x and the y. So if you were to divide those two things, you would get 1. And that occurs at 5 pi over 4. Okay, so 5 pi over 4 does fall in this category right here, but it doesn't fall in the original category that they gave us. So if we want to make this be a negative coterminal angle, we're going to subtract 2 pi from this to make the coterminal angle. So we need to make them have the same denominators. So if we want to have the same denominator, this would be 8 pi over 4. So negative 3 pi over 4 is going to be our radian measure that would be between the original interval that they gave us there. Alright, so if you look at number 6, it's already solved where tangent x equals 1 over square root of 3, so that part we're good on. It's from pi to 3 pi over 2, so that is on your unit circle. Pi to 3 pi over 2 is in quadrant 3. So we're looking for an answer for quadrant 3. Okay, tangent we know is y over x. And we're trying to find when y over x is equal to this 1 over square root of 3. So take a look in your quadrant 3. Do you see any values where we have 1 over the square root of 3? No. So guys, the only values we have are square root of 3 over 2 and 1/2, and square root of 2 over 2. Those are the only 3 choices that you have to pick from in this quadrant, okay? Not the ones in the zeros here. So if you want to make it look like this, what you're going to have done here, in order for square root of 3 to still be here, it would have had to have been a square root of 3 over 2 on the bottom, and it would have had to have been a 1/2 on top. Here's why. If you were to multiply or divide these out, you would do same, change it to multiplication, and flip it. So if you were to do that, that's where your 2's would cancel, and you would end up with that 1 over the square root of 3. So when you see this 1 over square root of 3, wherever that square root of 3 is, that's where your square root of 3 over 2 is to go. So we're looking for an ordered pair that has square root of 3 over 2 in the x value and 1/2 in the y value. So now we're in quadrant 3. If you notice, we don't have this exact point, but we do have this point right here where they're both negative. So the negatives are going to, since they're both negative, when you divide by negative, it will be positive. So that is going to be the correct ordered pair, and that happens at 7 pi over 6 for that answer. Alright, so if you look at number 7, so 7 says secant x equals -1, so it's already solved, so we're good. We're looking from 0 to 2 pi, so we're looking on the entire unit circle. So guys, this means there's a potential for 2 answers, so we've got to be wary of that. So secant goes with cosine. So if you remember, cosine is the x value. So the secant is 1 over x, and we're trying to find where that's equal to negative 1. You can think about it that way, or if you want to flip it around, you're thinking about where is the x value equal to negative 1. You can also think about it, where is the cosine value equal to negative 1? Those mean the same thing. So you're looking on the entire unit circle, you're just looking for when your x value, so it's going to have to be one of these main 4 points, is equal to negative 1. So the only place where that happens is at pi. Alright, and then for number 8, secant equals negative square root of 2, so it's already solved for secant, so we're good. We're only looking between pi and 3 pi over 2, so we're only looking in quadrant 3. Okay. So secant, like we just said, goes with cosine, so it's 1 over x, and we're trying to find whether that's equal to negative square root of 2. Okay, I would flip this around, so this is the same thing as when x is equal to 1 over negative square root of 2. Okay, so guys, if you look on your unit circle, and you can just look in quadrant 3, because that's where we have to look, you never see the point 1 over square root of 2, negative or positive. But if you were to rationalize this, that means to multiply by that square root that's in the denominator, that would give you the square root of 2 over negative 2. Or do we see that point on our unit circle? Yes. So if you look at 5 pi over 4, we have negative square root of 2 over 2. So that is the place, or the radian measure that we want to have at 5 pi over 4.